Let us consider another example, and in this example the objective is to use LCC, life cycle costing analysis, for finding out unit cost of water or unit cost of some item. We will consider a pumping application and then find out what is the unit cost of water, rupees per liter or rupees per meter cube. Let us first then define the problem. We will take a community of 100 people and the source of water is bore wells, and they are hand pumped by means of 6 hand pumps, 6 bore wells to meet the requirements of the 100 people in the community, and each person consumes about 40 liters per day. The bore well depth is 20 meter. The cost of each hand pump is rupees 5,000, and the cost of digging each bore well is the rate of rupees 250 per meter. The life of the hand pump is 10 years. The annual maintenance cost works out to be rupees 1,250 per hand pump. So if the rate of interest is 10%, what is the unit cost of water for a life cycle period of 20 years? So this is the problem. You must note that the numbers that I have given are contrived numbers, typical numbers, but they are not market numbers. So you will have to focus on the process of our calculation, how we proceed to calculate these numbers. You have to, at the time of executing the LCC analysis, you will have to actually go and get these numbers, this rupees price, maintenance cost from the market. You will have to get the realistic values. For now, focus on how we go about doing LCC. So therefore, let us try to achieve our objective of finding the unit cost of water. As before, let us draw a timeline, and I am going to have the starting point, and I am going to mark tick points. This tick point is 10th year, and this is the 20th year. Now we see that there is a life of the hand pump given as 10 years, which means at the end of 10th year we will have to make a replacement of hand pumps. There are 6 hand pumps, therefore 6 hand pumps need to be replaced. So there is a replacement that will come in here. So replacement cost of 6 hand pumps. Then the annual maintenance cost works out to be rupees 1,250 per hand pump. So annual maintenance cost means every year one is paying the AMC throughout up to the 20 years, 20 times we will be paying AMC. This is geometric progression. We know how to do that. We'll appropriately use the equations. And then at the beginning here we have to take care of the capital cost. So these are the calculations that we need to do. Capital cost, replacement cost, or annual maintenance cost taken together, all reflected, whether it be the replacement cost, the maintenance cost, all the time frames values should be reflected to the present time frame. That is the concept. Let us now calculate the capital cost K. So we should invest in digging 6 bore wells, and we know it costs around 250 rupees per meter into 20 meters and 6 of them, and therefore that works out to be rupees 30,000. Then we have to invest in the 6 hand pumps, and that is rupees 5,000 to 6 of them, and another 30,000. Add up all this, you get K is equal to rupees 60,000. Next, let us find out the replacement cost R. So you see that we need to do replacement of 6 hand pumps after 10 years. So 6 hand pumps to be replaced in the 10th year. So R is equal to 30,000 is the cost of the 6 hand pumps, and let us multiply it by the present worth factor 1 by 1 plus I to the power of 10, which will shift the value there to the present, and that is rupees 11566.30, and therefore R is 11566.30 because that is the only replacement. Next we will do the maintenance cost, M. There is the annual maintenance. We know what is given is rupees 1,250 per hand pump. So into 6 hand pumps will become 7,500. And present worth factor, PW, I will call it 1 by I, 1 minus 1, 1 by 1 plus I to the power of 20, N is 20, and that works out to be 8.51. This is the present worth factor. And maintenance is basically a reflection of all the annual maintenances into the present time frame, which is AMC, into the present worth factor, which is rupees 7,500 into 8.51. So maintenance is 63,851.73. Now LCC can be calculated, K plus R plus M, which is 60,000 for capital cost plus 11,566.3 for the replacement cost plus 63,851.73 for the maintenance cost. Everything works out to 1,35,418. This is the LCC, life cycle cost of this particular system. Now let us find out what is the annual LCC. Now if this value, the LCC, which is the worth today of this whole life cycle cost today of this whole system, let us see how we can distribute it equally for every year from today onwards till 20 years, which is supposed to be the life term, end of term. So the annual life cycle cost, ALCC, is LCC by present worth. We have done this before in the previous example. Similarly, LCC value by the present worth factor, which will give you rupees 15,906.15. Now this is the cost that would be incurred every year for this particular system. Now let us try to find the unit cost of water, the unit water cost. Let me move this up. So annual water requirement, how much water is required in a year? So there are 100 people, and we know each person takes 40 liters, so 40 by 1000 meter cube per day into 365 days in a year, and this will give you 1460 meter cube. This is the amount of volume of water that will be required. And now we can calculate the unit cost of water, which will be the ALCC, the annual cost for this whole entire system, divided by the water required, Q. So this will be 15,906.15. This is the ALCC value, divided by 1460 meter cube, will give you rupees 10.9 per meter cube. So this is the unit cost of water. What it means is, for every meter cube of water that is used by the community, the cost incurred is rupees 10.9. Or if someone wants to charge for would like to do a water billing for the households in the community, then they have to charge at least so that they recover rupees 10.9 per meter cube. This doesn't include the profits that the organizations, the building organizations would like to have. So in this way, we can calculate unit cost of water, unit cost of electricity, depending upon what type of system that we are actually doing the life cycle cost analysis. I have here for you a script file ex02.m. This is the script for solving the LCC example 2, calculation of the unit cost of water. A community has 100 people, it has 6 borewells, 6 hand pumps. What is the unit cost of the water for a life cycle period of 20 years? Data is given. Like before, I have classified into subsystem data: hand pump cost, borewell cost, life of the hand pump, then system specifications, number of people, what is the quantity of water required per person, 40 liters per day or 40 by 1000 meter cube per day per person, number of wells, 6 wells, well depth, number of years for life cycle costing, interest, AMC, the annual maintenance charges, rupees 1250 per hand pump. So these are the specifications. The life cycle costing, calculate K. We have found out the borewell cost, we have found out the hand pump cost. Add up these two, you will get the capital cost K. Then calculate the replacement. There is one replacement only for the 10th year, that is, you have to replace 6 hand pumps. The hand pump cost includes 6 hand pump divided by 1 plus I to the power of n, I to the power of 10. You get the replacement cost. Then calculate the maintenance. The present worth factor is calculated, and then maintenance is AMC into AMC here is 1250 per hand pump into number of hand pumps into the present worth factor will give you the maintenance. Calculate LCC, then calculate ALCC, the annual cube, the annual water requirement is basically number of people and per person how much he consumes per day into 365 days, and the unit water cost ALCC by annual requirement, which will give you in rupees per meter cube. Then I have the display section where I display the various parameters. So if you execute example 2, you will get the LCC calculations for that. The borewell cost, capital cost 60,000, replacement cost whatever we had calculated, present worth factor, maintenance cost, and the life cycle cost again what we had calculated, annual cost, and then you see that the unit cost of water is 10.89 rupees per meter cube. So I will leave it to you here again for you to experiment with different values for the system, put in realistic numbers and try it for your water pumping system, and try to calculate the unit cost of water using the script file and modifying the script file. I will share the script file with you in the resources section.